Morning friends. Today's topic is AC with resistor. So I am drawing a resistor R across an alternating voltage. So resistance R, the voltage drop will be taken as VR across the resistor. The next part is the first voltage equation is given as V is equal to Vm sine omega t, that I take it as the equation number 1. So here we are using resistor, so I am applying the Ohm's law. By Ohm's law, we have V is equal to IR. That is the second equation. You can see the left hand side and are equal. Therefore, 1 is equal to 2. So IR equal to Vm sine omega t. So this is the expression. So from this, we can derive the I expression. Therefore, I is equal to Vm by R sine omega t. So this is the expression. So you can see that as R increases, the value of current decreases. That is what I am showing by you by the arrow mark. So the next part is I is equal to Vm by R. So I is equal to V by R is the Ohm's law. So Vm by R, I take it as Im. So therefore I is equal to Im sine omega t. So when I am comparing both the expression, that is I take it as this as equation number 3. When I am comparing the first and the third expression, you can say I am comparing the first and the third expression. When compare it, you will see that they are in phase. That's what I am going to tell. So voltage and current are in phase. That is, voltage is in phase with current. Therefore, V and I are in phase, because since both the expressions end up with sine omega t, we tell that they are in phase. So when I am drawing the phasor diagram, most of them are asked how to draw that phasor diagram. So that is the part we are going to discuss out. So we will see that in phase means they will reach the maximum at the same point, minimum at the same point, but the value of the current alone changes. So when you are drawing a phasor, it is nothing but the vector representation. So by the equation, we are drawing it by a vector notation. That is the phasor. So now we are going to draw the phasor diagram. So the first you should draw with the graph. So when you are drawing the phasor, you should be drawing with the graph. Then only you can go with the phasor diagram, that is the vector diagram. So don't draw from the vector part itself. Draw from the curve part. Then you can easily draw the diagram neatly. And also it will be very easy for you to draw it. So first you have to draw from the graph. So I am drawing the first graph. It is nothing but taken as the voltage curve V. Now I told you that the value of as R increases, the current decreases. That's it. So it will not be having the same value. It will be lesser. The curve obtained will be lesser. So but the maximum values will be the same. So the curve will be 0 at 0 maximum, and at negative maximum also it will be same, but the value of the curve will be lesser. Now here we are drawing for the AC current. Therefore the instantaneous current or the IRMS value, we can take it as the IRMS value is given as 70.7%. So we should draw the graph exactly from, we should draw the phasor exactly from 70.7, not from the peak value. So first I draw, see here, for 70.7%. Similarly for the current curve also I do the same. So that is the phasor part. So the next part is, now we are going to draw the phasor in alongance with it. So I am going, just we are representing by a line. So I am ending the first line. So to voltage it ends. The next one to current. So for voltage and current, V and I have represented it. It is going with the angle theta is equal to omega t, rotating by an angular velocity omega. So this is the phasor diagram. So this part is taken as Im sine omega t. This part is taken as Im sine omega t. That is the current curve. whereas the other part is taken as, the complete part is taken as Vm